talk. Yeah, so this session will also be recorded for our own internal consumption, as well as we may share it in public domain as well. Okay, so first of all, let me introduce myself as well as my colleague. So my name is Victor Tan. I'm a deputy head of the Department of Mathematics in charge of undergraduate program. And with me, I also have Professor Ng Ka Lun. He's the assistant head, also in charge of undergraduate program. So both of us will be with you for this next hour, and I will be giving the program talk. And then both of us will also be answering whatever questions you have regarding the math program. All right. So if you have a question to ask, try not to type it in the Zoom chat, but rather post your questions under the Q&A in this Zoom session. Yeah, you should be able to see this Q&A. Yeah, so the questions will then be more organized, and then we will answer them accordingly. All right. So for the first half an hour or so, I will be sharing with you some information about the program. And then for the rest of the time, we will be answering the questions that you have. Okay. So I am going to start by giving you some reason or motivate you or incentivize you to consider doing mathematics or studying mathematics when you come to university. And I'm going to give you 5 important reasons. The very first reason is that you will be able to find good jobs if you do mathematics, or to be in the industry or sectors that are related to mathematics. I think one of the important factors students consider when they select the programs that they want to do in university is whether they can find jobs or not. And so what I'm going to show you is not just what I'm saying, right? So it's based on an article. And not only you can find jobs if you do maths, in fact, you can find good jobs. Okay, so this is actually the title of an article from Wall Street Journal. Okay, so this is a American-based journal or newspaper that published this article a few years back, but it is still very much relevant. Okay, so this article is based on the survey done by careercast.com. All right. So of course you may ask, how do you define good jobs? Yeah, of course, income, salary is one important factor, but it is not the only factor, right? Especially these days, I think Gen Z, when they think of what is good, how do you define good jobs, and so on and so forth, other than looking at the income. Yeah. So there are other 4 factors that this careercast.com take into consideration when they compile and then come up with a ranking and the list of good jobs. Yeah. So, for example, employment outlook, physical demand, the stress of that jobs create, as well as environment. Yeah, I'm sure that you more or less agree that these are also important considerations when it comes to looking for jobs and defining what is a good and satisfactory jobs, right? Okay, so what I'm going to show to you is that this survey, they listed down, of course, like 100 jobs, ranking from the very best to the worst. Yeah, so I'm just going to show you the top 10 list. And these are the some of the top 10 lists in recent years. Okay, so you see that there are 3 boxes here, so to speak, and each box is the survey done in a certain year, in recent years. Okay, and you notice that I've highlighted some of the jobs in red. Yeah. So I want you to think about what do these jobs have in common? Well, you can see that they are more or less all maths related kind of jobs, right? Yeah, like statisticians, data scientists, software engineers. Yeah, software engineers, actually, a lot of our maths majors, after they graduate, they ended up becoming a software engineer. Operation research analyst. Okay, so you might not have heard of the term operations research, but it is in fact one of the area in mathematics. Simply speaking, operation research deal with optimization. Yeah, so a lot of big companies actually hire our graduates, yeah, to become operation research analysts to help the companies or organization to optimize, their operations. Okay. Yeah. So, well, the ranking actually may fluctuate from year to year, but consistently you see that many of these um, maths related jobs are high on the ranking. Okay. Of course, we are not training all our maths graduates to become so-called mathematicians, right? Unless you are into research, right? You want to work in a research institution or in the university, become a math professor, then you call yourself a mathematician. Yeah, but our graduates actually may end up in many different sectors, which is in the later slide I will also elaborate. Okay. All right, so that was the first reason. Now, the second reason, there's a wide range of career choices. Again, this may actually come as a surprise to many of students and parents. Okay, and why is that? Is because there is actually a myth about what math graduates can do. Okay, a myth. So what I've shown you on the left hand side is a misconception, so to speak. A degree in mathematics can only lead to a teaching career, become a math teacher. Well, nothing wrong with becoming a math teacher, but what we are trying to correct the mindset of most people is that actually there's a lot of potential, like the name of my today's talk suggests. It can actually lead to many possibilities. Okay. Yeah, so you're going to see in my next slide, I'm going to list out some organization and some job positions as well as the sectors that our math graduates landed in. Okay. So on the left, you're going to see the various industry or sectors. Yeah. Education is just one of the many sectors. Okay, so we also see operation management, finance, information, technology, research, administration. And in the middle, you see those arrows. These are some examples of the titles of what a mathematics graduates can do. Yeah. So once again, on the first row, you see operation research analyst that was featured in just now the top 10 ranking, right? Then in finance industry, our graduates can also work towards the financial analyst, risk analyst, etc. Right? So yeah, I'm not going to read out everything, but just to give you an idea, what are the kind of career and job opportunities our mass graduates can have. And lastly, I'm also going to show you on the right-hand side some examples of some very well-known and big organization that hires our graduates in these areas and doing this type of job. Yeah. So I'm sure you can very quickly notice that we have big companies like SIA, DBS, Grab, Facebook, Google, and so on and so forth. Okay. All right. The third reason I want to share with you, multiple pathways. Actually, this is very important because mathematics actually is an area that's very versatile, right? So again, there could be a misconception that mathematics is just to, prepare our graduates to teach mathematics, but that is not really so. Of course, for those who are very passionate about mathematics, after you graduate, you can move on and continue to do maths-related jobs or can do further studies and become a researcher mathematician. But actually, many of our graduates, if they want to sort of switch career paths, they can also go into engineering, life science, finance, technology, physical science, etc., etc. Okay, that is because mathematics actually build a good foundation, and so especially for prospective students, if you can't really decide what you want to do uh, in the longer term, then mathematics is something that you can consider. Yeah, because and then you can think about where you want to branch out later on in your life. Okay. And this slide is interesting. The title is called Professors in NUS that are trained in mathematics. So you might think that if an academics is sort of like trained in maths, then probably he would just end up being a math professor like me in the Department of Mathematics, but not quite so. I'm going to show you that, for example, in NUS business schools, there are departments called finance department, operations. So it's actually quite mathematics based. Yeah. So there are some of our current colleagues in the business schools who they are in a bachelor degree trained in mathematics, but then when they go to their PhD, they may switch to finance, operations. Yeah. For example, the area of operations research is one of them that allows them to branch out to operations. Okay, so there are professors that were actually my classmates in the past. Okay, computer science, of course. Yeah, computer science and maths are closely related. So there are actually also many maths trained um, graduates that then continue with a computer science further studies, right, PhD, and then become a computer science professor. Yeah, we also have a number of professors in NUS in computer science that are originally maths trained. Economics as well. Okay, so yeah, so the stories is more or less the same. That it is not difficult. Yeah, if you have an undergraduate maths degree, then you can switch to econs, engineering, and closer to home, physics, statistics, etc. Okay, so I hope that that more or less gives you some idea. Yeah, you can switch paths quite easily if you started with mathematics. But conversely, I have to tell you that if you actually start from somewhere else and then later on you want to switch to mathematics, it may not be too easy. Yeah. So you go one way, but not necessarily the other. Okay. The fourth reason, myriads of real world application. Yeah, this is really important. Yeah, mathematics has a lot of application in real life and become more and more so as the world become more and more digital, right? Okay, so in this slide, I'm just going to highlight a few examples. Now, you may say that none of these so-called applications are directly related to mathematics. Yeah, or at first glance, you may not think of mathematics when you look at search engine, when you look at what human genome, options valuation, visual effect. But in fact, there are a lot of mathematics behind this. And that is why I'm not saying that mathematician can solve all these things alone. Yeah. So there's a lot of collaboration of mathematicians with the domain experts in the respective area, right? And work together, yeah, come up with research, come up with development in order to improve all these various aspects. yeah, to serve or to solve the real world problems more efficiently. Okay, so here I'm just going to highlight some of the mathematics topics or courses that are related to each of these associated to the real world problems. Yeah. So, for example, search engines, um, you need to have some foundation in graph theory, linear algebra, confidentiality, like the internet security, and so on and so forth. You need number theory and cryptology. Yeah. And of course, options valuation. This is in finance. Yeah. So you need something called the Black-Scholes model, Monte Carlo simulation, and so on and so forth. So once again, you might not have come across these mathematics courses or topics in your A level or whatever your um, current level of mathematics education. But when you come to universities, yeah, these are the courses that you can take and then to learn more about how all these different areas of mathematics can be applied to solve real world problems. So just to give you a very simple example, search engine. Okay, for example, Google. Now, some of you may say that isn't Google or search engine now sort of like obsolete because of all this Chat GPT or this large language model? Not quite so, because all these large language model at the back end, you still need a very efficient search engine in order to support. Okay, so imagine how does all this large language model response and answer your questions that you have. Well, at the back end, it will still need to rely on powerful search engine, right? So yes, it's still very relevant about search engine. So you know that one of the front leader of search engine is of course Google. Yeah. So just to demonstrate to you, right? If you want to search for, like, say, mathematics books, and I'm sure you still remember this is how Google is going to return you a list of website where you can find whatever information you want when you type in the keywords, right? So I'm here is just a demonstration. Yeah. So Google doesn't just randomly come up with a list that are relevant to mathematics books, right? It's very important, and that's why Google is the leader, that it has some algorithm in order to come up with the ranking. Yeah. So and based on these rankings, we know that these are the more popular, more useful um, website that is more likely to give you the information that you are looking for. And this ranking is so-called Google Page Rank. Now, what I'm going to demonstrate here is there's actually a very simple mathematics concept that is relevant in Google Page Rank. Okay, and that is under the top area of linear algebra. Linear algebra is the very first course that you are going to learn in the year one, right? If you are in the mathematics program. Okay, now in linear algebra, in fact, some of you at your A level or equivalents, you have already learned a bit of linear algebra, and you probably have been exposed to this topics or concept called matrix, right? Now, in matrix, there are many useful feature. One of them is so-called eigenvalue and eigenvector. And in fact, Google PageRank is based on eigenvector. Okay, of course, I have no time to give you more details how this works. Yeah, but if you come to NUS and take our linear algebra course, you'll find out. Okay. All right. So the last reason that I'm going to share with you why it's relevant to do mathematics is not just the content that you are going to benefit, but also a lot of life skills. Okay, the so-called lifelong learning skill. Yeah. So studying mathematics. Yeah, some of you may say that, okay, I learned all this about calculus, linear algebra. When I go to work after I graduate, I may not actually still do differentiation, integration, and so on and so forth. Yeah, and that is very true. But the kind of training that mathematics graduates receive during their studies in the university actually not only um, provide them with all this content knowledge, but also train them in the skills that I've shown you in this slide. Yeah. Most importantly, analytical thinking skills, which is something that the employers in the industry appreciate a lot from math graduates. Okay. Then, of course, problem-solving skills, rigorous and systematic. Yes, this is the very nature of mathematics. Yeah. So we introduce any math topics from the beginning, right? Define the meaning, and then slowly develop, establish some mathematics theorem. Yeah, so it's very systematic, and student will learn why certain things behave certain way, why does a certain concept have certain properties, and so on and so forth. Yeah, in a very rigorous manner. Okay. Yeah. So this is also what you will be trained to become. Yeah, very rigorous, very systematic, which is also very much needed when you are solving real-world problem. Yeah, quantitative reasoning, perseverance. Yeah, so it's not always very easy. Even for very good students, you may find that solving math problem uh, may not be easy. Sometimes you may take one whole day just to think about a problem. Yeah, unless you ask ChatGPT to help you to solve. Yeah, but otherwise, if you insist to try to solve a math problem yourself, which is, of course, there's a lot of benefits in it. Yeah, it's also training you to be perseverant. Yeah. Okay. So this slide showcase some, I would say, celebrity because you may not actually have heard of their name. But I'm sure that the organization that they come from are all everyone should know, right? Microsoft, Google, Netflix, Zoom, which we are using now, Pepsi Cola. Yeah. So what do they have in common? Yeah, the title already tell you the answer. They are all maths trained, or at least their very first degree is mathematics. They may not be using any real mathematics in their current jobs or when they set up their organization. Yeah, but definitely the training that they receive help them to be successful. Okay, I want to show you one person that's nearer to home. And this one, definitely you agree that is a celebrity. Okay, it's not a movie stars or TV stars. It's our former Prime Minister and currently our Senior Minister, Lee Hsien Loong. Yeah, I think many of you know that his first degree is actually in mathematics from Cambridge University. All right. Okay, so that is the first part. Now, the second part, I'm going to share with you the mathematics program in NUS. Just to provide some clarity, in NUS or in the College of Humanities and Science, we actually provide a few programs. There are actually a few programs that students can choose that are mathematics related. Or maybe I should say that these are the so-called quantitative programs. Yeah. So other than math, there's also statistics. So statistics program is a separate program. Yeah. Quantitative finance is a separate program. Data science and analytics, data science and economics. So for those of you who are with us this whole day, you'll see that there are separate talks on the different programs. So for my session, I'm just going to focus on the mathematics program. So in other words, if you decide to apply to mathematics program, then you will be a maths major. Okay. All right, so mathematics program is a 4-year honors degree program. That means when you graduate 4 years later, you will get an honors degree, your Bachelor of Science with honors, so to speak. Yeah. Now, 4 years is just typically our graduates will graduate in. There are students who can do things faster. They may finish within 3.5 years, or if they may want to take their time, go for exchange program, take a leave of absence to do internship, they may end up graduating in 4.5 or even 5 years. Okay, but 4 years is the norm. Okay, so how do you apply? So now is the university admission application season, right? So in order for you to apply to math program, let's say, you are not going to be able to see mathematics as one of the option. Yeah. So instead, you should select, yeah, when you go into the portal, you should select NUS, Humanities and Sciences. Okay. So in other words, mathematics program sits under the College of Humanities and Sciences. So if you want to choose mathematics, you just select NUS, Humanities and Sciences. Okay. However, I think you may be asked to also give an indication which program or what you want to major. Yeah, and you can indicate mathematics if this is your preference or something else. But this is just an indication. If later on you want to switch to maybe physics, for example, or switch to economics, it is still possible. Yeah, so this is just a preliminary indication that you can make when you go into the portal. Yeah, the important thing is to select humanities and sciences. All right. Yeah, so this is, I should have shown you this. Yeah, once you are being accepted, you can then officially declare mathematics as your major. Okay. So what qualification? Okay, so basically, overall, you should have your good A-level or equivalence result. So if you are taking A-level, right, those students who are under the A-level system, you should have a good H2 math pass in your mathematics or further mathematics, right? I would say that it's not just, it's a reference not just for us, but also for yourself. Yeah. So if you didn't do well for your A level in mathematics, then you probably want to think twice whether you still want to, major in mathematics or not. Yeah. Okay. So mathematics program, just to give you a little bit more detail, offer a wide range of pure and applied math courses and a wide spectrum of research activities. Yeah. So those of you who are very passionate, very interested in mathematics, you'll be spoiled with choices of mathematics courses to take. And if you are interested in doing some math project research, yeah, there is also plenty of opportunities. Okay. There is a optional specialization. Okay, so optional means that you can graduate without a specialization. But for mathematics, this is something that is add-on if you want, right? So we have two of specialization students can choose from. One is operation research and data analytics. Basically, this is like the applied mathematics specialization, as opposed to the other specialization, pure mathematics. So students that come to us, there are two types. One, they are really passionate about theoretical mathematics. Yeah, so these are the group of students. This is a group of students that will most likely specialize in pure mathematics. There are also another group of very good students, but they want to contribute to society, so to speak, that they want to apply what they learn in mathematics and go into the real world, right? So you can then choose to specialize in this operation research and data analytics. Okay. Okay, so I'm going to show you an important slide to give you a better idea what you are going to study in the 4 years when you come to NUS. Of course, for mathematics, you will have to do many mathematics courses. When I say many, actually it's not really that many. It's 15 courses in total. There's one foundation introductory course called the Gateway course, the basic discrete mathematics. And we have two versions. So students can either choose the non-T version or the T version. Yeah, you just need to do one. Okay. Then there are 6 other essential courses. Essential means compulsory. Yeah. So they are at the level 2000. Yeah. So most students will take the gateway and essential courses during their first and second year. Okay. And then in the final year, you see that there's a 4000 level project course. It's a capstone project. So whatever you see on the left-hand side of the screen, these are the compulsory courses, altogether 8 of them. Then the remaining 7 courses that you have to take to fulfill the maths program requirement are elective courses. Elective means you can choose. Okay? And I've listed some. So that's why I say it's a sample. We have actually a long list that student can choose from. And I've just listed the 3000 level. Yeah, some of them are pure maths courses. I think the first 5 or 6, and then the remaining are the applied maths courses. So as I said, these are just some example. Yeah. So if you don't like set theory, you can take number theory. You can take topological space, right? And for applied maths inclined students, you may take something like network optimization. You can take mathematical modeling, mathematics for artificial intelligence, and so on and so forth. Okay. And there are students who, we even allow students who take 4000 level elective courses to fulfill this 7 elective course. Okay. But the 4000 level courses is actually mainly for students who want to do specialization. Yeah. If you want to specialize on top of the 15 courses that you've seen in the previous slide, you have to do another 5 additional courses at 4000 level. And if you are under the pure math specialization, you have this list of, I think there are 12 courses that you can choose from, right? 12 choose 5. Okay. And if you are in the ORDA specialization, you also have a basket of courses that you can choose from. Okay. So this is just to give you an idea. Okay. So I also want to mention a few other so-called special programs. The first one may be of interest to those students who are also very interested in computer science. Okay, so this is a double degree program. What does a double degree program mean? It means that the students will get 2 instead of just 1 single degree. Okay, now the double degree programs that I'm going to introduce in this slide are our collaboration with School of Computing, or more precisely, Computer Science Department. Okay, so the first double degree program is computer science and mathematics. So students will get a degree in computer science and also a degree as Bachelor of Science with mathematics. Okay, so this is for those students who want to do both. Yeah, and the reason that we come up with this structured double degree program is because computer science and mathematics, they are closely related. Yeah, so we are leveraging on the synergy between mathematics and computer science and offer this double degree program. So double degree program doesn't mean that you have to do 4 times 2, 8 years. So typically students can still finish within 5 years. As I said, there are a lot of common courses that students can actually double count in both programs. Okay. Okay, the other double degree program is something new, and you might be excited to know. So you're just in time, right, to consider this new double degree program in artificial intelligence and mathematics. Okay, so the artificial intelligence program itself is under computer science, right? And they are again collaborating with mathematics department to come up with a double degree program for students who are strongly interested in mathematical foundation and especially in the area of machine learning and artificial intelligence. Okay. So if you are interested in this double degree program, actually you can apply for it and indicate in the portal when you do your admission application. How to do that? Okay, so the first step is always to select the course of choices. So you can choose humanities and sciences. Please mute yourself. Okay, let me. Okay. Okay. So a little bit different from the previous slide. So you can select this double degree program directly. So this is so-called direct admission. Okay. So you will be able to see an item called computer science and mathematics. You can also can see this combination of artificial intelligence and mathematics that you can directly apply as one of your choice. Okay. Other than double degree program, we also have double major program. Okay. So double major program means that you have one primary major. So let's say, of course, I'm interested in students doing mathematics, right? So let's say you have a primary major in mathematics, and then you can also combine it with a second major. So here I'm going to highlight 4 of them. The first one is a collaboration with business school. So it's math and management. The other 3 combinations are with School of Computing. So again, there's business analytics, there's computer science, there's information security. So we can do a double major program with this 4 combination. Okay, so some of you may be wondering what is the difference between the double degree program of maths and computer science versus the double major program of maths and computer science. Well, double major programs, you are just going to earn 1 degree, and then you should be able to still finish this double major program within 4 years. Okay, because it's less intensive. How to apply? Okay, so the first step is always the same. So you choose humanities and sciences as your course of choice. And then you can also indicate you want to select a DMP with whichever combination. You'll be able to see these 4 combinations. Yeah. So this is again direct admission. Okay. Now, I need to clarify that these are not the only DDP and DMP combination. In fact, there are many, many other possible combinations students can design their DDP or DMP. Okay, but they are not so-called structured DDP or DMP like the one that I've introduced just now. Students have the so-called flexibility to design their own DDP, DMP, right, in many other areas of discipline. Okay, but for this kind of student design double degree or double major program, you will only declare and apply for it after being accepted to NUS. So in other words, when you go to the portal to apply for your NUS courses, you just select NUS Humanities and Sciences, but you do not need to select DDP and DMP if your combinations are not the one that I mentioned just now. Okay, so in other words, these are not through direct admission. Okay, I hope that is clear. I'm almost coming to an end. So for this special program in mathematics, okay, this is not a so-called degree program per se, but it is a value-added programs that mathematics department provide for students with a very strong passion and aptitude in mathematics. Okay, so this selected group of students, I think they appreciate and benefit through rigorous training and special design courses with close mentorship. Okay, that means the teacher-student ratio is small. Yeah, and this is particularly beneficial for students, especially if they want to go to continue for their further studies to do a PhD program in mathematical science discipline. Okay, so this special program in mathematics, as I said, it is not a degree program. So you do not select it or do not apply it through the university admission exercise. You are not going to see this appearing in the portal. Instead, we will select students based on their academic results in their first semester, provided they have chosen the relevant math courses, right? And they get good grade. Yeah, then they can apply for it. Okay. All right. So almost coming to an end, but I just want to point to you that more information you can find on our website. Let me help you to navigate a bit. So there are many items in the menu. Go to the undergraduates. Okay. So, of course, the first item, prospective undergraduates, there you will find many useful, relevant information for your to help you to make decision. But just now, I mentioned those major programs. You can actually click on this second item, major and minor program, and in order to go into and look at more details of our program. And then we hear that we also have information about the double degree with School of Computing, right? And also special program in mathematics. Yeah. The rest may not be so relevant, but feel free to explore. Okay. Okay, so I think I'm going to stop soon and open for Q&A. Yeah, so this coming Saturday, we also have a physical NUS open house, and we will have booths set up to answer students' questions. If you have more questions about the mathematics program, do visit us at NUS University Town. So the location is stated here, and talk to one of our program advisors. Okay, so once again, on the right side is the QR code that leads you to the mathematics webpage. And I'm going to open the Q&A now. But if your question didn't get answered satisfactorily, or you have other questions after today's session, feel free to email askmathsug@nus.edu.sg. Okay. I will also be repeating the program talks physically during the NUS open house, but it will be the same. So if you have already gone through today's my talk, then you can skip that and then better use your time to explore other programs and so on. Okay. Okay. Before I open the Q&A, this is a QR code, which is the feedback. So do try to scan this, and then later on you can submit your feedback about today's session. Okay. All right. So maybe I should stop sharing now. And wow, I think there are quite a number of questions.
Yeah, Victor, maybe let you take
a break.
Short break. Yeah,
Yeah.
I've tried to answer some questions during your talk, those that involve short answers, but I think there are still quite a fair bit. Let me quickly try to get a few more answers through.
Okay, thanks.
So I think one of them is, for example, as a gauge, right? How many students take major in math every year? So I think this one is simple answer. Typically, we get about 80 plus minus every year. Of course, because math is what we call open major, so there's no restriction, there's no quota. So some years we get more students who are interested in doing major. Sometimes it can be higher than even 80. So there's no restriction. That's why it can only be a rough gauge lah. So that's the first one. The second question, someone asked, what is the difference between a level 3000 and level 4000 course? Now, not just for math, NUS, our courses are based on what we call a prerequisite system. So most of the courses require prerequisites, meaning you need to read something at a lower level first before you're allowed to do a higher level course. So the level 3000 and level 4000 gives us some indication as to the order in which they should be taken first. So typically you would read the level 3000 course maybe in your second year, late second year, or your third year. And then in your third year, late third year, or even in the fourth year, you take more advanced courses in level 4000 courses. So the difference here is in terms of, the level of mathematical maturity that is assumed that a student would have by the time they take a level 3000 versus a level 4000 course. The preparation level is a bit different. Okay, then there's one question about, is there a bell curve in NUS math? So I think there's this myth that there's this bell curve. So there's not to worry, there's no bell curve. At the end of the day, when we assess the students, we really look at whether they have, demonstrated that they have attained the necessary intended learning outcomes for all the courses that we teach. All right. So if the students have demonstrated that they have achieved those outcomes, then or achieve to what level of those outcomes, then the grades that they get will be indicative of what is deemed to have they have demonstrated, not just in the final exam, but throughout the series of continuous assessments from day one during the semester. Is it easy to get a high distinction if one is not a further math or SMO student? Of course, right? So there are many of our math majors. They have not taken further math. They have not taken SMO competitions before, but they still end up doing very well, getting high distinction honors degrees at the end. So I think it's not necessary that you must have taken further math or have experience with SMO kind of competitions. Victor, any question you see of particular importance you want to quickly address first while I look through the rest?
Okay, so those are the 27s under open, right? So they more or less answer. Maybe those answer we can just say answer live and then we'll
Yeah.
Okay, there's a question asked, is it less advantageous using maths degree to apply for jobs of more specialized fields like data scientists, quants, and analysts, and less prepared for such job? My understanding is that not so. I mean, whether you major in maths or QF or data science, it is still basically providing a, a foundation. All right. Yeah. So it's true that QF students, quantitative finance students, they may learn a little bit more about some financial knowledge in their undergraduate program. Data science students may learn a little bit more about some of the data-related courses. Yeah, but I do not see that it is a disadvantage of for the maths major students. If you actually try to look for some internship, in the relevant field that can actually enhance your experience, hands-on experience. Yeah, and I would say that if you do more maths, relevant maths courses, it can actually a plus. Yeah, it can be a plus. Yeah. So there are students who actually would like to do math because it is more versatile and more flexible in terms of choosing courses. Yeah. So if you're in data science, DSA or QF, it is very structured. Yeah, you have less choices. Yeah. So there are pros and cons, so to speak. Yeah. But I must say that math graduates, many of them also landed with jobs as data scientists, quant analysts, and so on. Okay.
Mm.
Um,
Okay, maybe I
yeah.
take one quickly here. So there's a student asked how to be enrolled in the math special program. I assume you are referring to special program in math. So this one is upon application. So you need to apply to be considered into the program. And one of the first things you should do is, just now Prof. Tan was saying that the one of the compulsory course is this gateway course called MA1100. There is a T version to this course, MA1100T. So if you like to be considered for the special program in mathematics, then I would encourage you to take the T version of the course of MA100. Really get a good sense of, how a typical course in the special program in math is going to be conducted. It's probably in a smaller class setting, and then the treatment of mathematics there is a little bit more rigorous. And if you enjoy it and you do well in it, then you apply to be considered into the SPM program. Okay, another question about doing a double major in mathematics and econs. Is it
Double
able to do
degree.
so?
Is it?
There's some question on double degree, there's some question on double
Okay.
major. So just want to make sure that students are clear. There's a difference, right? So double degree means you get 2 degrees by the time you graduate. All right. So if you do a double degree in mathematics and econs, then you have a Bachelor of Science degree arising from your math major, and you have a Bachelor of Social Science arising from your econs major. So you get 2 degrees. Right. However, there's a double major, which is just a single degree. So a single degree means you have a primary major, in which case, let's say it's mathematics, then you have to fulfill the major requirement there, which is 15 math courses. And then your second major is econs, right? And second major in econs is 10 courses, right? So by the time you graduate, 160 units, you have fulfilled the 2 major requirements, primary major in mathematics and the second major in economics, then you'll get a single degree with 2 majors, mathematics and econs. Right. And when do you apply for these? So mathematics with econs, even as a double degree, is not a direct admissions. So you need to come in first, whether into CHS, and then apply to be admitted into the double degree program in your second year onwards. So you got to do well in both the majors that you intend to double degree in. All right. Same thing for double majors. So double majors, you come in with a single major first, then you can declare a second major plan in your course registration exercise at the beginning of every semester. Okay.
So the students, other than asking about the double degree in maths and econs, also ask what is the criteria to study maths in NUS apart from the cut-off. So from the university's perspective, there is no other criteria. That means if you are being accepted to humanities and sciences, then you are free to declare mathematics as your major. I think the criteria actually come more from the students themselves, right? They have to know whether they are really interested in mathematics, whether they have the right attitude, mentality to study mathematics. Okay, it will be quite different from studying mathematics at A level or equivalent, I would say. I get a job in engineering if I focus on pure mathematics. So just now in my talk, I said that, yeah, for students who want to specialize in pure mathematics, you fundamentally choose courses under the pure math basket. But there's nothing stopping you from also select some courses that are more applied in nature. Okay, so yeah, so optimization, operation research, these are also very useful topics, even if you decide to specialize in pure mathematics. Yeah. So the short answer is that yes, it is still possible to land a job in engineering. I'm sure you don't just mean software engineering, but all kinds of engineering. It is possible. Yeah. Is year one content the same as those taught in H2 further maths? And then the other question is also, is H2 maths content relevant for NUS math? I would say that the foundation course, especially like calculus, linear algebra, and probability, there are um, some overlap, something that may look familiar to those students who are A-level or equivalent. But you are also going to see that they will also be treated or introduced in a more rigorous manner. Yeah. So the approach may be different, although the concept may look familiar to you. Yeah. So we are using the foundation years maths courses as like a transition, as like a bridge for students, to smoothly ease into the higher level advanced math courses. All right.
Okay, one here that says, I heard that for one major there will be 160 units. Actually, it's not true. 160 units is the entire degree requirement. So you get one degree. You fulfill the degree requirement, it's 160 units. The major in the CHS, that our majors are all 60 units, which is 15 courses only. All right. But there's a common curriculum, there's an unrestricted elective. So all these will add up to 160 units for a single major, or if you can do a double major, it's also possible to squeeze it into 160 units because you can use your unrestricted elective space, all right, to fit in 40 units, right, which is 10 courses. But if you do a double degree, then depending on what is the double degree combination, all right, you typically will need to exceed 160 units depending on what is the combination and whether there's sufficient overlap or double counting. All right, the total number of units that you need to read in a double degree program is typically around 180 plus minus units.
Okay, that's an interesting question. Is it true that NUS Maths is more to prepare students to be a researchers, while NTU Maths is more focused on applied mathematics? This is totally not true. Okay, so our maths courses, as I said, we not only offer pure maths courses, we also offer applied maths courses, and a lot of them. I think we have even a wider range of applied maths courses. And among our professors, we have a lot of very excellent world-class mathematicians who are not only experts in pure mathematics, but also applied mathematics. Okay, so for students who come to us to do mathematics, they want to get a good education in order to apply their maths in the society or in their job. NUS will prepare you for that as well. Not to mention that we also train students well to become researchers. Okay. Some
Okay, a student asks further math does not, is it true that further math student does not have any advantage over H2 math student? I think by virtue of the fact that if you have done further math, you would have done more math than somebody who have just done H2 math, then that would count as an advantage in a way, right? Because you've been exposed to maybe different aspects of mathematics. Maybe you have been exposed to more proofs, or you've seen more techniques in proof writing or examples of proof writing. So having done further math would purposely mean something. There's definitely an advantage, if I would say. All right. But then again, it is not absolute that this advantage would translate into something that is insurmountable, and therefore somebody with H2 math only would certainly do not as well as somebody who has done further math. So I think the advantage is certainly there in terms of exposure, but it doesn't necessarily translate something into something that is very tangible.
Let's pick some more question. Have we already answered this? How is math program different from quantitative finance and statistics? So as I mentioned just now, maths program offer a wide range of courses, so it gives students more flexibility, while quantitative finance and statistics are more focused, so to speak, right? So quantitative finance, of course, is training students specifically in for the finance industry. So the courses that they are taking, the foundation courses are still very much similar to maths program, maths major. Yeah, but at the higher level, they will focus more on, let's say, finance knowledge. and those uh, concepts that are more relevant if a students want to be a quant analyst. Okay, and statistics. Well, I mean, at A level, we all treat statistics as a subset of mathematics, right? Yeah. So in fact, statistics, of course, there are certain aspects of statistics that is kind of beyond mathematics, but there are certainly overlapping area, right? Some stochastics analysis, probability. Yeah. So these are some overlapping um, courses or topics. Yeah. But once again, statistics is also very much um, focusing on dealing with data related area or discipline, unlike mathematics, which is have a wider application. Okay. How do I decide on which type of math is more suitable for me? When you say which type of math, uh, maybe at this point you are just referring to pure maths or applied mathematics. Actually, to be honest, most students, I would say that they are not too sure when they enter university. Yeah, but it takes time for you to explore and to experience for yourself, experiment for yourself, what you really, what is really your liking and suitable. Yeah. So you can take some courses that are more related to pure maths and some courses that are more applied maths inclined. And then you can make a comparison. You can also talk to your academic mentors as well as seniors, yeah, to help you make a decision along the way. Okay. What types of job does each of these program leads me to? Honestly speaking, as I said, whether you are applied maths or pure maths specialized, or even there's no specialization, you can do similar types of jobs. Yeah. So as long as you do well in your undergrad mathematics, I would say that you will be in demand in the industry. Yeah. Okay, the difference between the double degree program in math plus computer science versus math plus artificial intelligence. Okay, so of course, the math part will be the same. That means that when the students choose to do a double degree program, they have to fulfill the program requirement for the 2 degree. Yeah. So of course, the math part in the combination means that you fulfill all the math requirement. Okay. Then the computer science or the artificial intelligence part, they have different lists of programs that you need to fulfill. Of course, if it is artificial intelligence, then the list of compulsory courses will most likely be all related to AI, machine learning, and so on and so forth, right? So it's sort of like focus students more on the AI aspects, yeah. Whereas for computer science, it will be the more typical courses under computer science, yeah.
Okay, the question here, if one wants to be a math teacher, which math shall one take? So I am assuming you are asking which math courses, right? So there are many courses that the math major can choose. I would say that if you want to be a math teacher, of course, even at the secondary school or the JC levels, a lot of the math that is taught there are the foundational ones, right? So calculus, linear algebra, and so on, right? So I think having if you have done the foundational courses in the math program and done them well, all right, and have a good solid understanding of these foundational topics, that would prepare you that should prepare you to be a math teacher. But of course, being a math teacher is not just about teaching those to your secondary or JC students. If you want to engage them further, you need to expose them and you need to tell them more about how math is used in other areas and why math is important and so on. So that you would have to have acquire sufficient knowledge after taking other maybe higher level courses in the math program so that you'll be equipped with those understanding and examples or applications so that you can share it with the students in your classroom. Okay, so I think whether which are the math courses that you take will all be useful, right? But the foundation ones are definitely the bread and butter that you need to have a good understanding and mastery level, because those are bread and butter, right? But beyond that, to engage students further, then that depends on your own interest, right? Which aspects of mathematics you are more interested in.
Okay, I also see a question. What is the difference in the double degree program? There's computer science and mathematics versus mathematics and computer science. So it's just like a permutation. Which one comes first? So in fact, they are both referring to the same double degree program. So it's just that if the computer science come first, it probably means that your home faculty, right, is is SOC, right? But if mathematics come first, then that means CHS is your home faculty, or faculty of science is your home faculty. Yeah. So it really depends on when you go into the portal whether you choose uh, your course of choice as humanities and science, or whether you choose it as computing. Yeah. And then the double degree program is the same for both. Okay. Is there any point in doing maths to enter data science industry if I can just major in DSA, DSE instead? Okay, so DSE is again rather focused, right? Is mainly focusing on economics. Of course, I must say that economics is also quite broad in itself, right? So maths, if you do maths, I must say that the advantage or the benefit is that your training in mathematics part is more in-depth, right? So if you major in DSA, DSE, yes, you can go into data science industry, yeah, but there might be some limitation of how far you can go without further training in your maths. Yeah. On the other hand, if you are trained in maths, if you are a maths major, you can also gain all this data science industries experience by doing internship. So I cannot say for sure that who actually have the advantage of whether if you do mathematics is not really helping you to go into the data science industry. Yeah, so we do know that data science, AI, all these are advancing very quickly, right? So what we train in math students is they learn fast. And this is also what the industry's employers appreciate of math students. This is their feedback and comments about math trained students. They learn fast. Yeah. So in this world, things keep changing, right? You have to keep learn new thing. Yeah, it doesn't mean that you major in data science and will just be like smooth sailing in the data science industry. Yeah. So there in future, there will always be learning, relearning, and so on and so forth. That I think in math major students will be well trained and positioned, yeah, to take on. will there be scheduling clashes between the compulsory core courses of the two degree? So this is the questions about study plan. Yeah. So for the compulsory courses, as much as possible, we will try to take a look and try to avoid any conflict. But sometimes it's really we can't avoid. Yeah. So students may have to work around by coming up with a study plan and try to take it in a different semester. Okay, but typically for those foundational large classes, we will have more than one lecture group. The student have the flexibility of choosing one over the other in order to avoid any conflict in scheduling.
Okay, just very quickly, direct admission. So direct admission is not the same as aptitude-based admission. So direct admission, normally when you hear it, it means for certain programs or certain degrees, all right, there is a quota where you have to apply directly into that program upon admission into NUS. So it is not a major that is free for all to declare where there's no quota. So for example, in the Faculty of Science, the major food science and technology is a restricted major. So people will apply directly to be admitted into that major itself. If you're accepted, then you are into that major. However, for a major like mathematics or statistics or data science, these are not direct admissions. Right? The moment you get admitted into CHS, then you'll be able to declare these as your majors with no restriction on the quota, right? Like only restrict to 200 or 300 students. There's no restriction. Okay, aptitude-based admission is different in the sense that if your application, your results did not make the cutoff point, then based on your aptitude, right, in your application, you can also be considered to be admitted into CHS via one of these aptitude-based admissions routes. Right, so this is different from direct admissions.
So there's a question asking about the math special program or special math program. May I ask, would B students qualify for special maths program? B as in you get a B for maths, H2 maths. As I said, we do not base on a student's A-level result at all. All right. So you may be just happen to have a bad day during your A-level maths, H2 maths exam day that you didn't do well, but actually you know yourself that you are good. So, well, you still have a second chance when you come to university. You take the foundation courses, math courses, and you do well. We may still take the student in for the special program. Okay.
Okay, one question here. Can math students join quant easily or need to study CS? So I assume the quant here, you mean quant finance industry, right? So I think my understanding from my interaction with the quant finance industry is that they are looking for students not particularly in any major, right? But they are looking for a profile of students that are very quick in their thinking and analytical in their ability to solve a problem or to analyze something very critically, creatively, all right? So therefore, whether and systematically. So whether you are majoring in mathematics or you are doing a degree in CS, all right, if the training in that major provides you with the kind of foundation that these quant trading firms are looking for, then you will have a good opportunity. So from our point of view, I think in the past many of our math majors, right, have been interested and also successfully joined the quant trading industry upon graduation. So it doesn't necessarily mean that they have to do a second major or second degree in CS in order to attain that kind of level of competency in having a very critical and analytical mind in terms of problem solving. Okay.
Yeah. Couple of questions asking about gender. Okay, what's the gender proportion for students studying mathematics? Is it true that 80% are male, 20%? To be honest, there are more male students than female, but it's not the gap or the difference is not so wide. And I hate to say that whether maths is more suitable for male as compared to female. We do have some female students who did very well. In fact, we last year we just have um, uh, female colleagues who were graduated from NUS Mathematics, yeah, and then went on to US to do her PhD, and then now come back and join as a professor. Yeah, so there are female math students who did very well, exceptionally well, and yeah. So we do not want to stereotype. Yeah. The big difference between maths and data science major. Um, okay, so the maths courses, the maths training that students get, um, in a way is more theoretical. Yeah, but I wouldn't say that it is theoretical is not equivalent to useless. Okay, compared to data science, it's more hands-on. Yeah, so this one we have to admit. Yeah, it's for the different students with different preference and what they really like in future. Yeah, so data science, of course, all the courses are relevant to data, analyzing data, right? Data mining, yeah, machine learning, and so on and so forth. Yeah, so there is a scope for students who are majoring in DSA. Yeah, for math students, as I said, we also have this specialization in operational research and data analytics, right? So there is also a potential for students who major in mathematics and specialize in ORDA uh, to join the data science industry and be able to do well. Okay. May I ask, would you say that the math degree is the best, better than QF? And no. Okay, so once again, it really depends on what uh, a lot of factors and consideration. Yeah. So if you come in as a student, already know that you want to work in the finance industry as a quant analyst, then I would say that a quantitative finance major program, it will be more suitable for you. So it's all about suitability. Yeah. But if you are still shopping around, cannot make up your mind, or you want to have more options at the end, of your 4 years of uni education, then maybe math degree is something that for now more suitable for you. Okay. Okay.
Okay, there's a last question here, the latest one that was asked at about 4:10 about applications, H1 not calculated, and so I understand that this year, because there is a change, right, in the way the university admission score is computed. So at the department level, we are not entirely sure at how the admissions office in the university looks at this particular scenario that you have highlighted here. So if you can, it'll be good if you can visit the open house, the physical open house this coming Saturday, and then approach the admissions office desk or the admissions section over at our CHS booth at the Sports Hall 2, right? I think with colleagues there, we'll be in a better position to give you advice on this particular situation that you've highlighted here. Right?
It's something new to us. So
Yeah, yeah.
yeah. If one want to be a researcher, what type of math shall he or she takes? Mention that quantitative finance is to prepare one for finance. I wouldn't say that there's any particular courses that you should take to become a researcher. But if you have that in mind, that means you want to go further studies, then the the special program in mathematics will really be very helpful. Okay. So within this special program in mathematics, there are 4S courses that you have to take. So you take these S version in place of the regular compulsory courses. Yeah, so that is, yeah, I would say the training itself is more important than the particular math courses that you should take. Yeah. Kalun, you also want to answer this question, is it? Or is it done?
No. I was just looking at the list
Oh,
and
okay.
clearing those that
Yeah,
we have
yeah.
looked at. Yeah.
Okay.
So yeah, I'm not sure how many of you are still here in this session. In case we have not been able to cover your question, so please look at the I think slides that Prof. Tan mentioned gave earlier. That I think there's a, QR code and a email that you can drop us an email, or better still, visit us this Saturday at our NUS open house, and then you can talk to us in person. You may have more questions by then. We look forward and we can answer your questions in person on Saturday. Any other ones we need to do?
Scan through again. How shall I prepare for NUS math courses before uni starts? Okay, so we are going to have separate engagement session in April for those students who have opt for mathematics. So if you have selected mathematics and being accepted by NUS, you will hear more sharing from us on this in this area. Okay.
Okay, what is a requirement to further study in math? What is the GPA I need for me to study masters in mathematics followed by PhD? So I think there's a difficult difficult question to answer specifically, because different master's program may have different requirements, not just necessarily looking at GPA. They may also look at other aspects, sometimes, and of course, PhD programs as well. So I think it's maybe a bit too early to be worried about this at this point. All right. After you have started your journey as a mathematics major, and depending on how you progress along, then feel free to talk to the professors that have taught you or is teaching you, or your academic mentors, if at that time you would like to consider doing a postgraduate degree. So maybe at this point, there's really not no need to worry about this at the moment, because like I say, a lot of the postgraduate programs, their admission requirements can vary.
Maybe let me also add on, for the master program in mathematics in NUS, the rough gauge is that you should graduate with a bachelor degree in the second upper honors class lah. Yeah, that's a rough gauge. PhD, I don't think is so much depending on GPA. Of course, you have to do well in your math courses, and then like what Prof. Ng said, there are other consideration like a good recommendation letters from professors, your own personal statements, your experience, and so on and so forth. Yeah, so that's more relevant for PhD. The cutoff for double degree in math and computer science, I believe, is straight A.
Yeah,
Yeah.
it's a very competitive direct admissions, but um, uh, direct admissions into the double degree program for math and computer science is not the only way to get into this double degree. So there is also what we call the midstream admission. So even if you're not successful at the upfront, that means right now, all right, what you can do is to let's say you declare yourself as a math major, and then you try to do the computer science courses as well. And if you've done very well in both the math and the computer science courses after 1 year or 1.5 years, 3 semesters, at that point you can apply to be considered as what we call the midstream admission into the double degree program between math and CS. So it is competitive because it's really demanding. But even if you're not successful at this upfront admission stage, it's not game over yet. You can still try again later on, 1 to 2 years into your candidature.
There's one rather advanced students, they asking about taking 5,000 level courses like Lee theory and representation theory. And he asked whether you can take those courses without the SPM. Absolutely, right? So SPM actually is a choice. It's not we select the students to be in this program. Students self-select as well. So there are students for various reasons, very interested in maths, but not necessarily want to be in SPM. Yeah. And if you satisfy the prerequisite, we do allow students to take 5,000 level courses. If I did H3 maths, how doable is it to learn coding for DDP? I don't really understand this question. Are you more concerned about DDP with computer science that you need to use a lot of coding? Well, fundamentally, for whether students are in DDP or in just single degree mathematics, you are required to do a coding course, CS 1010, under the CHS common curriculum. Yeah, so that will give you some basic training of coding. Yeah, and well, definitely, if you want to be in DDP, you should be comfortable with coding. Yeah. Is there any math sample class, that means master class, at the US Open House? I think this year we do not provide master class. Yeah, but like I said, during our engagement, we may actually try to come up with something, yeah, that looks like a sample class for to let students have some preview. How do I find out whether I'm suitable to study maths? Um, if you're saying at this point, the only thing you probably can only base on is your A level or equivalence result in your mathematics subject. But if you're talking about after you are in, let's say in CHS, um, you definitely can talk to seniors, talk to professors, talk to your academic mentor to find out more, and also based on your own experience taking the math courses. Right. So like what we have said, you can you have the you can still change your major if you find out that a certain program is not suitable for you. Yeah, of course, we do not encourage students to keep changing every semester. Yeah, but more or less, you should have some idea after 1 or 2 semesters with us. I think we pretty much clear everything, right?
Yeah.
Very last
Think
questions
so.
about the difference between learning in computer science and artificial intelligence. There are overlap, definitely, but what I mentioned earlier on, artificial intelligence is more uh, geared towards courses and topics that are relevant to artificial intelligence, like large language model, neural network, machine learning. Yeah. Whereas computer science are the more traditional computer science program courses that you will embark on. Yeah. Okay. Good. Thanks for all the questions and for attending this session. Yeah, if you have further questions like what Proven mentioned, we hope to see you on the fiscal open house this coming Saturday. Yeah, and definitely would like you to seriously consider taking up, applying for the mathematics program at NUS. Okay, so I think we can end the session.
Thank you everyone for coming online. See you on Saturday.
All right, so we will end the session now. Bye-bye.
Bye-bye.